Okay, thank you very much. You've all been listening to all these speakers in the morning, sitting back, relaxed. That should change now, because you need to do some work as well. As I'm gonna ask you to think about linking and to think about the data we work with and how the type and the nature of our data influence the linking that we want to do, but also influences the tools we want to use to create these links. And one of the central themes of this hands-on session will be the balance of thinking about what we can do automatically and where we need the human in the loop. So I'm going to focus on linking in vocabulary sets, but I think many of the problems and the issues and the solutions that we're gonna see today are also applicable to other type of links. But in this session, I'm gonna focus on interactive vocabulary alignment. So this is making links between vocabularies, between concepts in vocabularies. And for those of you who attended the TPDL conference last week, then you know already what my theme is for this talk. I think we stole from Tolstoy's famous opening of Anna Karenina and adapted it a little bit for our purposes. So happy alignments are all alike, and every unhappy alignment is unhappy in its own way. I'm not going to explain this, but I hope that during the talk you'll think, now I know what he mentioned, what he meant by this. So, very briefly the project context, because if you've paid attention in the morning, you should already know this. We talk about aggregation of collections from different organizations. And all these collections come with metadata describing the collection items. And in the descriptions of these items, people use terms. And sometimes these terms, for instance, in a DC subject field, is free text. But more often, it comes from a predefined set of terms that is being used for that collection. And these predefined term sets, they come with different names: authority files, thesauri, terminologies, subject heading lists, ontologies sometimes, etc., etc. But for this talk, I will just all call them vocabularies. And then my question is, if we want to link across different collections, different vocabularies, how are the terms in these vocabularies related, right? And a set of such relations we call an alignment. So that's just the introduction and the terminology I'm gonna use. So the real question is, my first question to you, why would we do this in the first place? Why are we interested in making relationships between terminologies? And I've heard quite a few of potential reasons, potential motivations to do this. But I would like to hear your opinion about this. So has anybody in the audience thought about this problem? Have a comment on this? Maybe you have a good motivation not to provide these links. Can I give the floor to anyone? And I'm willing to prepare to wait quite a while. So if you want to make this boring, then feel free. I can wait.
Is this supposed to be interactive?
There's not going to be a hands-on session without your help. So cross-reference, yeah. So what do you mean by cross-reference? Search over collections with different vocabularies. Yeah, so that's a very good one. So one of the advantages of having such links is that you can search in one collection using the terms that was previously used by the other collection. For instance, a collection that you know, you're now going to want to search in a set of collections that you know less, and you're not familiar with the terminologies used there. So if you have all these cross-links, you could use your own terminology and still find usable results in another collection. And there's also, this applies across collection, but also applies across languages. So if you search in one language, and you have in your own language a vocabulary that's linked to vocabularies in other languages, and these vocabularies are used to annotate collection items, then you can also do cross-lingual search. Are there other issues or reasons, motivations? Create mashups. Can you give a concrete example?
Different data sets about the same object, and you can collect the different data from different places and display it in one page.
Okay, thank you very much. So mashups, linking different descriptions about the same object. So in Marcus' talk just before, the question was, are two, for instance, different records talking about the same person? And how can we decide this? Can we do automatic mashups of, if you're looking at one object, automatically give, for instance, suggestions about other objects made by the same person? Then you need to know if you're talking about the same person, also across collections, across vocabularies. Okay, so one of the important questions that we come across time and time again, when we look at two terms from two different vocabularies, they are similar, but the big question is, are they sufficiently similar for our purposes? Right? Because things can be similar along one dimension, but very dissimilar, very different from others. And more often than not, the correct answer depends on your task, on your applications. What do you have in mind? What are your goals? What do you want to achieve? It might also depend on the user. So in our lab, we have done many experiments trying to evaluate the quality of alignment tools. And then the question, again and again, is if two people judge the quality of the same set of alignments, come they to agreement about which ones are good and which ones are not? And one of the things we have learned is that in the domain of cultural heritage, more often than not, people cannot agree. If you give them very, very strict instructions of what they have to approve and what they should disprove, not approve of, they still have very big trouble agreeing on which alignments are correct and which ones are not. And sometimes similarity relationships are not enough. So Guus briefly mentioned the other mapping relations that SCOS defines. But even the SCOS relations, like exact matches, close matches, related matches, narrow and broad matches, are just a very basic subset. You can go on and on thinking about other relationships that you might want to use. And this makes it even more complicated. So, for instance, another question, who knows the difference between a SCOS exact match and a SCOS close match? And I can be frank, I had to look it up in the SCOS recommendation myself just before the talk, because I didn't know. So who can give the answer? Antoine, you're not allowed to answer this. Yeah. Can you use the mic, please?
I think the exact relationship is transitive.
Exact relationship is transitive. That's a very. Do you know what this means? Because I think many people here might have no clue what that means.
It means that if two are exact and the third one is exact with the second one, then all of them are exact.
Yeah.
So it propagates.
Very good. So if A is an exact match to B and B is an exact match to C, then also A is an exact match to C. Very good. And close match does not have that property. So one of the informal ways that it's explained in the SCOS recommendation is that if you apply an exact match, that means that you are very, very sure, very confident that you can treat these two concepts as similar across a wide range of information retrieval applications. And if you say close match, then you say, well, maybe for some applications this can be treated the same, but I'm not making statements about other systems. But then the difference between close match and related. Right, so I had to look it up. And related is an associative link, full stop. Doesn't explain what the difference is between a close match, something that's very similar, but not always, and a related associative link. So Antoine, can you explain this one to me? Because I don't know. Where's the boundary, right? So when there's a close match stops being a close match and becomes a related match?
That's a good one. Yeah. Actually, it depends on the. Well, you would expect actually that there are about different, really different meanings. So
okay.
There would be kind of a relation that you can identify which is not equivalence or similarity. So yeah, between, for example, a person and a role that a person can play, or kind of a job, for example, and a discipline, that sort of thing. So actually, that just mirrors what exists in the thesauri already. So mostly, it would depend on the modeling decisions that have been made in the thesauri prior to their conversion to SCOS.
So I think one of the rules in the thesauri is if something is related, if two terms are related, they can never be also related in the hierarchy, in the broader and narrower term list. But still, we find that if you look at concrete examples and you ask people to judge if this is a close match or a related match, people often don't agree. So let's go to a concrete example. Suppose we want to align terms from the Getty Art and Architecture thesaurus, the AT, to WordNet. And this is actually an example from an experiment where I was one of the participants, and I was asked to judge this relationship. So on the one hand, we have the AAT term, restore. It comes with a number of alternative labels. So this is all based on a conversion to SCOS of AAT. It comes with a different number of alt labels in different languages. And it has a scope note that starts with those restorers are people those engaged in making changes to an object or a structure. Nobody. One brave. So who thinks this is more an example of a SCOS close match? Can we do show of hands? 1, 2, 3, that's more. 5, 6, 7. Who has just no clue what the relationship should be? Who thinks it's a SCOS related match? 1. Who thinks it's a SCOS broad match? Guus? Oh, that restore WordNet. The WordNet one is broader than the AT one. So AT has broader the WordNet one. Just one. And a narrow match? Okay, these numbers don't add up, right? So from this I conclude that the other of you either don't have a clue but are not willing to say this, to admit this, or you think that SCOS doesn't apply here and we should really have a different type of relationship here.
One of the definitions is wrong.
One of the definitions is wrong. Yeah.
So I'm going to throw one of those out. I know which one.
Okay.
But the problem is with the data.
Exactly. So well, this is an interesting remark. So this is actually a comment that we receive a lot during these evaluation sessions, right? I cannot judge this because the data is wrong.
But if we take, is it on? If we take that position, Europeana will never work, because in all the data sets, things are wrong. We have to live with that. And that's, I think that's something that is part of, it's a feature of linked open data. It's a feature of the web, actually. And it's not a bug. It happens. People from different perspectives take different names, and it's very dangerous to say it's wrong, in my opinion.
Okay, that's a very one.
Maybe one definition is just incomplete.
Well, it is incomplete because I didn't show you everything. So this AAT scope note actually goes on. And then it's for you to decide if it makes things more clear or more confusing. So it continues to say, okay, when changes made are to prevent further deterioration, see preservationists. So don't use this term, use another term. More generally, for those who undertake treatment, preventive care, and research directed toward long-term safekeeping of cultural and natural heritage, C, conservators. So also don't use this one. So this has changed your opinion about what the nature of this relationship should be? Did this thing make things more clear or more confusing? I have to admit, when I read this, I'm just more confused. Right? I now think that the AT term is so specific that it is a narrower term of restore. So this just changed my opinion, actually. But what I want to achieve with this is that you appreciate the problem, right? This is not a trivial thing to decide on. And it is an interesting question if we trust computers to make these decisions for us. And then if we do so, can we trust the results? And this is not for one term, right? There are 100,000 terms in WordNet. So we have to make this decision a lot. And we need to be able, can we trust the results? If we do this 100,000 times, we get 100,000 of these relationships. For which practical purpose would you be willing to put your money on the table and say, okay, well, we're going to use this in our search system, in our museum or library to do query expansion, for example, automatically, or to do suggestions? Are the results good enough for your purposes? And if not, for instance, if we publish this on the web as linked open data and you find it, you think, hey, that's handy. This is a nice alignment between the two vocabularies that I need. How can you know if you can trust these data sets or not? And if you think, okay, then if we cannot trust it, we shouldn't use it, then we should do it by hand, right? But most of the data sets we have are just too large to do completely by hand. Especially in Europeana, where you have to deal with many vocabularies. And a lot of them actually are over 100,000 concepts each. We have to do some automation. So this is a difficult problem. And when you look at the performance of automatic tools, then we can see that alignment is indeed hard. Right? So, and one of the things we found out in working in Europeana Connect, but also in other projects, is that in our domain, automatic alignment tools basically perform very bad, or just completely fail, on all data sets that differ from the data sets they've been tested on. And that's not that surprising, but it becomes really bad when you analyze the reasons for failure. And one of the things we've done is in every use case where we analyzed the failure, we found different reasons why it went wrong. So it's not as simply just fixing the tools to make them deal with our data. Our data is so different each time that making a tool adapt to all these different cases is actually very hard. And this in our lab became known as the Anacarena problem. Right? So here comes back the central theme of the talk. These alignments that work well, they tend to be very similar. They're all the typical cases where the tools are tuned for. But all the other cases where it doesn't work well, and these are a lot, they don't work well for a different reason every time. So this is actually a very hard problem for us computer scientists to fix. So when we look at the tools that currently out there, the state of the art, that for instance compete in this ontology alignment evaluation initiative that's been held for quite a number of years now, where they actually test tools on the same data set to compare their performance. You see that current systems are very smart and complex reasoning engines. Right? So they know that alignment is difficult. They know that with one simple strategy, they will not compete very well in this competition. And they all apply multiple strategies at the same time. And what's even more smart is that they combine these strategies in different ways depending on the situation. So these are very smart tools. But this smartness also has a price. And I think in our field it is a too high a price to pay. Because it makes it very hard to predict if it will work on your data. Right? So if you have an alignment problem with two vocabularies that you want to align, and you look up in the literature, you have to make a decision, okay, which one of these tools I'm going to try. Because trying them all is very expensive. But from this literature, you can only see how well they perform on the test sets that are used in these experiments. And how that translates to your data is very hard to predict. So in advance, you have no clue what the result is going to be. But also afterwards, once you have run these alignment tools, and they've created 100,000 alignments for you, then the question is, okay, how good are these 100,000 results? How do I find out? And if I, for instance, if I sample a small set, and I found out that they did very bad, how do I fix that? How do I do a second run where it's better? And also, a thing we learned is that most of these tools don't even work on our data sets, right? They go out of memory error even during loading of our data sets, because they are made for small ontologies with 100 concepts, 200 concepts, 1,000 concepts. That's a lot. But when we do 100,000, 300,000 concepts, like for instance in the library of Congress subject headings, they just crash. So how to solve this, right? That's difficult. And I'm from an AI lab. And basically for me, this is a kind of a failure of AI technology in this particular domain, in this particular problem. So the proposal is to do something radically different, and to throw out all the AI, to throw out all the smartness from the tools. So we're just going to give up on making these tools smarter, and we go back to the basics. Right? And we put all the smartness back in the humans in the loop. So we're going to need the domain experts to make the smart decisions. And in the tool, we only use very, very simple atomic matching components, where I hope I can explain to you. These are so simple that I can explain to all of you how they work, what they will do, on which datasets they will perform well, on which datasets they will perform very badly. Very simple things. And the performance of these components, they will be much, much worse than the state of the art, right? So the F measure is the mean of the precision and recall figures. It will be very, very bad compared to the state of the art. We know that. But they will be very fast. They will be scalable. They will work on our scale of the vocabularies, on big vocabularies, large vocabularies. And they're going to be predictable and understandable. They're going to be predictable in advance. You should be able to predict if it will work or not. And if you run them, afterwards you should be able to understand the results, the good ones and the bad ones. And of course, if the performance of an individual component is not good enough, how are we going to improve on that? Well, we're going to need the domain experts to do that. And we propose an interactive loop where the domain expert decides which component to try. So that's already a first decision. He or she should analyze the results to see if it was a good attempt or a bad attempt. And then decide, based on these analysis, on what to do next. And please pay attention, because you are going to be doing this in the next demo. Right? And the typical decisions are, if you tried something and you analyze the results, that you think, oh no, this was horrible. This was just a stupid mistake. I shouldn't have done this. Just throw it away. But then, it sounds bad, but you have actually learned something, right? So you've learned why it didn't work. And what was the property of your vocabulary, or the source vocabulary, the target vocabulary, that didn't make it work? Or maybe you thought you understood my component, but actually you didn't, and now you do know why it works or doesn't work. But more common is that you think, okay, it's sort of okay, but not quite, and the precision is not good enough. So from the results, there are many bad ones, and I need to filter out the bad ones to improve my precision. Or you look at it and you think, oh, it's sort of okay, but the recall is not good enough. So I found some stuff that's interesting, but I didn't find many more other relationships that they also would want to find, and I need to do something about that. And then you get into this interactive loop. You do this again and again and again, until you come to the moment you think, okay, now this should be good enough. So before I'm going to ask Antoine to come up the stage and to run a demo with us, where you can actually do this live, I want to give you run you through one example, just to give you an idea how this works in practice. So the The use case here is of a typical use case. It's an in-house thesaurus, in this case from the Dutch archive, National Archive on Audiovisual Archive. It's called the GTAA. Doesn't matter what it stands for. And we want to map it to a lexical resource. It's called Cornetto, and you can see Cornetto as a kind of the Dutch WordNet. So the whole approach is based on human knowledge. So there will be no help from the tool making smart decisions. So we have to do all the things ourselves. So we should start with looking more closely at these vocabularies and see what it actually means for our alignment task. And when we look, for instance, at Cornetto, it's much like WordNet, and it has many homonyms. So there are many words that have different meanings, right? And that spells trouble. That's gonna, if we're gonna do a lexical matching, we're gonna find many, many, many wrong homonyms. So we should already think about that, how to deal with that. And when we look at the domain thesaurus, the source thesaurus in this case, we see that most of the concepts actually are nouns. And since Cornetto is split up in nouns, verbs, adjectives, adverbs, that might actually be useful. But not all of them are nouns. That would make it too simple. Some actually are verbs. And for those of you that don't speak Dutch, in Dutch, the plural of a noun is often the infinitive of a verb. So that also spells trouble, right? So we should also be careful with that. We also note a very common problem here is that thesauri typically use plural forms of nouns, because that's in the ISO standard. While on the other hand, lexical resources like Cornetto, they're more like a dictionary that uses the singular form of nouns. So here actually a technique like stemming might help, right? And I said might because I'm not sure, because stemming also gives problems in terms of precision. And if it actually helps or hurts, I'm not sure. And finally, when I look at the domain thesaurus, I see that it uses preferred terms and alternative terms. But when I do a sampling, I don't usually like the alternative terms. So there are many cases where I think, oh, this alternative term is not really an alternative term. It's more a later term or it's a narrower term. It's not like a synonym. So using these alternative labels might gain us in recall, but it can actually hurt us in precision. So I'm also not quite sure what to do there. So back to you. How are we going to do this? Right, if you should do this, where would you start in the alignment process? So you know this. Now what? We can, for instance, if you take the example of the AT or WordNet, we could compare glosses, scope notes, right? Would it work in this case? If I do an exact, make it simple. If I do an exact match on scope notes, how many hits do you expect I will get? Stefan says none. Does everybody disagree with Stefan? I agree with Stefan. Right? The chances that two different organizations describe the term with the same scope note is just very close to zero. I don't expect any results there. If I do an exact match on the preferred labels, how many hits percentage-wise do I get there? So if Cornetto is complete and GTA has concepts that have labels that are proper Dutch, you might hope for 100%, right? Anyone? So you all work with thesauri, right? So if you think about what's in your own thesauri, in your own thesauri, in your own organizations, are these terms all proper English or French or Dutch words. Typically, there are many named entities, right, where that wouldn't show up in a dictionary. So there's not going to be a golden method that works for all things. We just have to try things and see what works. So I'm going to try, in this, what I did in this use case, I just tried exact matching on preferred labels first. But because I wasn't sure about the alt labels, I also tried exact label matches on preferred and alternatives, both. And because I wasn't sure about stemming, in extension to the exact match, I also tried stemming, just to see what would happen. And of course, if you have a tool where all these things take a week to perform, it would take you 4 weeks to do this experiment. It would be a very expensive experiment. But if you have a tool where you can do this interactively and it takes you a few seconds, then it's actually a very useful experiment to do. And so like I said, my first try, my first iteration loop would be to match all the nouns in Cornetto to all the concepts in the domain thesaurus with and without stemming and with and without alternative labels. And I'm going to give you a demo, show a demo in a minute about how you can do it in the tool. But for the moment, the important thing is you need a tool to do this. Because if you have to do it by hand, it wouldn't work. If you need to hire a programmer to fix this for you with a couple of shell scripts, it will also not work. But we have a tool to do this. And then I can look at the results, right? So if I do exact preferred label matches, I get about 1,100 something results. If I also include the alternative labels, I get more results, but not that many more. So this is a bit disappointing. I would expect a lot more results. But anyway, if I include stemming, then as I expected, I get even more results. Actually, a lot more, much more than I expected. And if I do stemming on alternative and preferred labels, I get the most results. So that is an increasing list. I sort of expected because the matching technique becomes more general. But the way it increases, I didn't quite expect. But anyway. So if we go for precision, we might take the first one. If we go for recall, we might take the last one, right? And which one is better? Depends on your situation and your goals. So let's do a little bit more analysis. And also, we have a concept that's called arity splitting, which basically is a technical term for looking at which of these mappings are ambiguous and which one are not. So we look at all these mappings, and we throw all the ambiguous mappings in one bin, and we throw all the other mappings in the other bin, and see what that gives us. So the second column is the non-ambiguous bin. And there something strange occurs. Right? So the first column was nicely increasing expected, but here we have something strange going on. If you look at the non-ambiguous results, you actually see fewer results when you use both preferred label and alt labels. So matching on preferred labels alone gives you more non-ambiguous results. So that's something I would have never expected. And it can be a very particular property of this data set. That could never happen, maybe it never happens on any other data set. Right? So this is just an example of this unhappy problem. All these unhappy alignments are unhappy for their own sake. So now is the question, what do we do with this? Anyone? Is this a reason not to go for the last option? Well, I was assuming, okay, if we go for recall, I better take the last option because that gives me the most results. But then if I look at the non-ambiguous results, I might better go for the third one, right? So how do I decide this? Can I, by staring at the statistics, can I make an informed decision? Of course, the answer is no, because what the real question here is, this extra ambiguity, so this jump from 700 something to 1,000, are these good results or are these bad results? So do I really lose only stuff by introducing alt labels, or I also gain something and look at the ambiguous results and actually find there a lot of good stuff that I don't want to miss out. And by staring at these statistics, I'm never going to find the answer. So I need to do more work. So what I did is actually what Michiel, maybe he's in the audience, what Michiel did, is he looked at this 300 results that we get extra and did a sample of that, actually a sample of only 25, and he just investigated what kind of ambiguity is causing the problem here. And maybe I can, from that, I can learn something that allows me to make a more informed decision on which one to use, but maybe also on how to proceed in the next step. So we looked at this, and there are different types of ambiguity actually going on. So sometimes it happens that we have one target concept over here. Let's do the other way around for you. One target concept over here, one source concept over here, and we have two targets in the other, in Cornetto, in WordNet. And the two targets are actually related by a broader than relationship. And this actually happens quite a lot, because if the source thesaurus is more general, more generic than the target thesaurus, you have things that are nicely split out in different hierarchies in the target that are crammed into one in the source. So it actually happens quite a while, happens quite a lot. But it's also easy to fix, right? Because if you know that if you want to have both, then you just leave it like this. That's fine. If you want only the broader term, then you select only the broader term, that's fine. And if you only want the narrow term, that's also fine. And if you want to make complex links with close relations and narrow than relations combined, that's also fine. So once you know that this is a problem, and once you have decided what you want to do with it, solving that automatically is actually not that difficult. And we also have targets where there are no broader than relationships, but these are siblings in the hierarchy. So actually there is the same story. If you know what you want to do with this problem, it's very easy to solve. Some of these targets are true homonyms. That is already what we expected, because we knew that Cornetto had many homonyms. So that's, we should have been warned for this. And actually, when you look at these kind of matches, you see that typically one of the homonyms is the right one, the right sense you were looking for. And then you see that in the hierarchy above it and in the hierarchy below it, you find many other matches for the children and the parents of your source concept. While in the wrong sense of the word, which is just a freak accident, you will not find these other sets of matches. So actually, it's also a very simple one once you know how to deal with it, to deal with automatically. And then there are things that are, there's a small set of things that are not so easy to solve. And those are things that are related terms that are crammed into one set in the source vocabulary. So for instance, an example here is that we have a concept that has as preferred term beekeeping, and as alternative term honeycombs. Right? And then you can say, that's a bad thesaurus. But I don't control the thesaurus, so I cannot change the thesaurus. So I need to deal with this somehow or another. So this is what our analysis learns. And then we need to decide what are we going to do with this information, right? So one of the things I have decided is that I like these unambiguous matches, because I think they're good enough to keep and to work with. And this I'm going to call my first result set, so L1. These are all the things that are unambiguous, exact label match. I trust these. If you agree with that, that's another thing. If you don't agree, you need to do further analysis on my dataset, L1. But if you agree with me, then you can use this because it's a trustworthy data source. And then because I found that actually the ambiguous mappings have lots of useful stuff for me that I don't want to throw away, I'm going to decide to improve that ambiguous set and try to pick out the good stuff and throw out the bad stuff. So I have these target relationships that are broader than, and I decide that I only want to keep the broader and ditch the narrow ones. Right? So that's a decision you might or might not agree with, but once you have decided that running a matcher that actually does this is very easy, and we're going to see examples of that in the demo later. The sibling terms, I decided that they are good enough for me, and I just keep them all. So I don't need to do anything, anything else there. And I call this my third data set. And these homonym problems I'm going to look at by matching the parent and children concepts. And then I can find the right homonyms and ditch the bad ones. And because I find new matches, I can run this same algorithm another time and find new matches. And actually, if I do it 3 times, I find even more matches. And if I do it 4 times, I don't find anything new. So there I stop. And this is my results at 4, 5, and 6. Now, if you get doubts here and think, I'm not going to trust these 4, 5, and 6, that's fine. I also have my doubts here. But you can decide for yourself if you want to use this or not. That's the idea. And then I think I'm done with the ambiguous noun matches, but I also want to improve my recall, and I also want to look at the verb matches. So I do a similar loop at the verb matches. And actually here I do an exact label match. Again, I ditch all the ambiguous mappings in one bin and all the unambiguous mappings in another bin. And if I look at the set of ambiguous mappings, there are not that many of them. So I decided just to evaluate them manually. And when I do the evaluation, I came across problems where I know they're also in the other set, in the unambiguous set. So I also decided to do the manual evaluation of the other data set. And this gives me 2 other data sets, 7 and 8. Right, so this is the, and now I think I'm done. This is good enough for my applications, for my purposes. This should be fine. So what do we have done? We have now 8 different sets of mappings. And by the way, they cover over half of the source thesaurus, the domain thesaurus. Now the question, of course, is what's going on with the other terms that we didn't map? Are these concepts for which we just simply didn't find the mappings because our strategy was bad? Or are these concepts for which there is no mapping in Cornetto? Right? There's only one way to find out, is do more experiments on this data set and do manual investigation of that. It's beyond the scope of this talk. But for each of the data sets we did find, we know how we have created them. And we can explicitly give all the design decisions that were involved in creating them. So we know which ones we trust and which ones we cannot trust. This strategy we interactively built, and we're going to see an example of that in the tool later, allows us also to replay this whole experiment. So if you, a year later, find problems and you think, okay, I want to do this again and find what's going wrong, you can do this. If you want a year later run the same experiment but on a different version of a newer version of WordNet or a newer version of your in-house thesaurus, that's easily done. You can just press the button and replay the whole experiment. The provenance of all this information, where it came from and how it was created and by whom and when and where, on which machine and on which software versions, etc., etc. This is all also recorded in RDF and is published with the data. So if you make this linked open data, then you can not only publish the vocabularies and the links, but you can also automatically provide all this provenance information in standardized formats. In this case, the OPM vocabulary. And I'm going to give you an example later. So this type of scenarios, we have done quite many of them for the Europeana Connect project. So I just mentioned a few of the examples here. But, there's a big but, all of these are done by members of our team, of our lab. Right? So my real question, my research question, that I cannot answer right now is, can domain experts really do this? Right? Because that would be great. If domain experts can do this, then we would turn Anna Karenina into a feature. Because typically domain experts are very proud of the unique features of their own vocabularies. They know of them, and they can exploit them. It would also give me a lot more buy-in for my data, because if instead of a computer that we don't trust created the mappings, the domain experts themselves created the mappings, then much more people, including the domain experts themselves, would trust the data. But wait a minute. Who are the domain experts, right? The domain experts are you. So the real question is, can you do this? And to be frank, I hope so, but I'm not sure. So I'm going to ask Antoine to come up to the stage and just find out, right? So we're going to try to live do an alignment of a mapping that Antoine needs to make